Hello everyone, my name is Viran Raj and my metric number is 181061452, and today I'm going to talk about the overview of our project. So when it comes to the continuous monitoring of an event, place or people, the manpower that is required is extremely costly. The use of drones for monitoring purpose is clearly effective. So today I'm going to talk about the hardware and software of our system. Okay, now I will talk about how this project will run. Our project will focus on surveillance movement of the surrounding. We will focus on aware the dangerous situation when there is an intruder appearing in the surroundings. The next one is we'll focus on protecting the safety of the users. We will use the drone to monitor the surrounding and the users can know any intruders trying to surpass. After that, this project will focus on tracking with GPS modules. In this situation, the user can locate the position of drones and can identify the position of the intruder. In addition, it can provide timely disaster warning and assist in spreading up rescue and recovery operations. Surveillance drone can quickly provide coverage of large area without ever risking the security or safety of the person involved. Moreover, this device can be used to monitor real-time construction project sites. Okay, this is the hardware of our project, and this is our next stage of our project. This is software part, and it's done by the Raspberry Pi module using a camera to take video of the surrounding.
Hi everyone, my name is Yihang. So my metric number is 171061086. So in my section, I will explain about how are we going to build up a drone and how a drone can fly in theory. So as you can see in this picture, this is a drone picture. And usually this is where we put in our motor, and here's our propellers. So when the battery provides power to the motor will spin and provide torque to the propellers. And when all the propellers spin, it will provide thrust to the whole drone system. And if the thrust provided are greater than the weight, the drone will lift up and fly. So if the user wants to change the direction of the drone, we will adjust the thrust provided from these propellers to make it go to the direction that we want. So in the next picture, this will be showing our frame, our drone frame, which is a 36x36 frame. So there are 4 arms here, and at each end of the arm will be attached our motor and our propellers on it. And in the middle plate of it, will be attached our microcontroller, our receivers, our cameras, and battery. All kind of components will be attached in the middle to ensure you have a center of gravity is stable, as all the weight is attached in the middle. So in the next picture, I will be showing our connection in a schematic. So as you can see in this schematic diagram, on the left is our receiver to receive is a 4-channel receiver to receive signals from the user by using a transmitter. And this MPU 6050 is a gyroscope to make sure the drone is flying in a level state, it won't flip up. And on the right side is a ESC, which is called as an electronic speed controller. So this electronic speed controller will receive signal from this Arduino Uno. Then he will tell how fast should the motor spin in order to make sure the drone is flying in a various situations. So there are 4 motors attached here, 2 of them going in clockwise and 2 of them going in anti-clockwise direction. So this is how a drone can fly, and the whole system is connected with a battery, which is about 11.1 volt battery. So that's all from me to explain about the drone's connection and also on the theory how it can fly.
Good day to everyone. My name is Tan Ying Xuan. In this project, I'm in charge of developing apps for camera system for surveillance drone. These app systems have been developed by using MIT Inventor 2. Now, I'm going to share the MIT screen preview for more details on the apps for the camera system in the surveillance drone. In MIT App Inventor, here is the designer platform, and here shows the block platform. By looking at the screen section, we have 2 screens. Screen 1 is this, which I've shown here, and screen 1 shows that the system is the front cover of the apps, and whereas for the screen 2 is the display of the camera system. So if we wanted to enter the IP address to the system, we just needed to enter in this part where it is a text box. We can enter our own IP address for the camera system. So the camera will display in this part, and we even have created a stop button and a play button. and even an exit button which we can exit from the app system. So let's look to the block platform. For block platform for screen 1, we have our own loading system, delay system, which we need to delay for the preview for our own app system and to download some system for the next screen. So for the screen 2 block system, we have button 1, button 2, we even have a web viewer 1, button 3 and notifier. For button 1, which shows that the camera button, and if the text box has been filled out with the correct IP address, the IP address, we will click on the button 1 and it will be directly bring to the web server, and we can even view our own camera system on that platform. So when the stop button, which is button 2, have been clicked, and we will return to the own original page, which is a very empty page, and the text box will automatically deleted and will be empty space on that time. For the third button, which is the exit button for the apps, it uses to exit the app system. When I wanted to exit the system, the message will show that the selection of message will jump out and will ask me, do you want to close the apps? So that in this notification, we have two buttons. It's either yes or no. So if we choose yes, we will go out from these apps. If we choose no, we will just remain on this app system. So if we enter the wrong IP address, we can see that here, error occur in the web viewer if we set an error code into the text box. The message dialog will show that we have wrongly input the IP address. So we need to try again by entering the new IP address to the text box. So this is the MIT block function for the overall apps.
Bismillahirrahmanirrahim. Assalamualaikum and good day. I am Muhammad Ikhwan Fidaus bin Alwi from IDP Group 7, where for this project, I did the camera part. The camera will be used and attached to the drone, which acts as the eye of the drone when it's maneuver around the selected place, where it capture and record every movement that happened in the selected area. The camera that we are using to attach at the drone is the Raspberry Pi camera version 1.3, where it costs less than 20 ringgit at the current online market. The resolution of this camera is 5 MP with the weight of 3 gram, and it contains a sensor OmniVision OV5647 with 2592 times 1944 pixel, with the focal length of 3.6mm, tolerance plus minus 3.6mm. The horizontal field view is 53.63 degrees, which is the best range for the surveillance purposes. To enable the camera on the Raspberry Pi, we need to use this command, which is the sudo raspi config, and enter. We choose the number 3, the interface options, and yes. At the first option, there is the camera. To enable or disable the connection to the Raspberry Pi, we choose the first one, and yes, okay, and then we click finish. And the red light at the camera is a light up, which indicate the camera is enabled. For monitoring purpose, our group chose to use MotionEye OS. MotionEye OS is a Linux distribution which turns the single board computer into video surveillance system, which supports all versions of Raspberry Pi. This is the app developed by Tan Yin Swan, where through this app, the user just need to add the IP address and the user can monitor the live streaming which is recorded by the surveillance drone.